Here's the thing about the AWS Developer Associate exam. AWS loves 4-option questions where 3 of them sound exactly right. The one you pick comes down to one keyword. Execution role versus resource policy. GenerateDataKey versus Encrypt. Provision versus reserved concurrency. SSE-C versus KMS. Today, we're going through 10 real exam-style questions. And I promise you, at least 2 of these will catch you off guard. Let's find out which ones. Welcome to PrepMyCert. This is the AWS Certified Developer Associate Certification. 10 questions. 10 chances to test yourself before the real thing. Let's go. Starting with Lambda. Easy on the surface, but most candidates pick the wrong directory and pay storage cost forever. Your Lambda function processes files and creates many intermediate files. You want to discard them after the function exits. Where do you write them? C/TMP. Every Lambda execution environment gives you 512 megabytes of writable space at /TMP by default, and you can configure it up to 10 gigabytes now if you need more. /opt is where Lambda layers mount. That's read-only. S3 works, but you'd be paying storage cost for files you're about to throw away. And bundling a TMP folder inside the deployment zip doesn't help, because the package contents are read-only at runtime. /TMP is the only writable file system in a Lambda execution environment. Next, scaling Lambda for a known traffic spike. This is where 2 answers look almost identical. A retail team is preparing for Thanksgiving traffic. They want to eliminate cold start latency on their Lambda functions during the surge. What's the right approach? B. Schedule application autoscaling to manage provision concurrency. Cold starts happen because a brand new execution environment has to be initialized. That's the latency you're trying to dodge. Provisioned concurrency keeps a pool of environments warm and pre-initialized, so requests skip the cold start. Application autoscaling ramps it up before the event and back down after. Reserved concurrency caps how many concurrent executions a function can have. It limits. It doesn't pre-warm. Lambda does scale automatically, but the first request into each new environment pays the cold start tax. And an application load balancer in front does absolutely nothing for cold starts. Switching to S3. Sharing an object with a specific group securely. You have JSON files in an S3 bucket. You need to give a specific group of people temporary download access. What's the secure approach? V. Generate a presigned URL via the AWS SDK. Presigned URLs grant time-limited access to a specific object using your signature, without exposing credentials or making the object public. The other options all leak too much. Object retention controls deletion protection, not read access. A time-bounded bucket policy is error-prone and would expose every matching object to anyone with the URL. And static website hosting makes the bucket public to everyone. That's the opposite of secure sharing. Presigned URLs are exactly this feature. Now S3 encryption. For options that sound similar, only one matches the requirement exactly. Pay attention to the keyword. Company policy requires server-side encryption with customer-provided keys for all S3 operations. The app uses the AWS SDK for put, get, head, and copy. Which encryption method? C. SSE. The C stands for customer provided. S3 does the encryption work, but you supply the key on every request, every put, get, head, and copy, and S3 throws the key away after the operation. AWS KMS uses keys managed in AWS KMS, not raw keys you provide. SSE-C3 uses S3, managed keys with zero input from you. And client-side encryption isn't even server-side. Your app encrypts before sending. Match the keyword to the right letter, and the answer falls out. DynamoDB capacity math. This is the question most candidates get wrong because they skip the rounding step. Take your time on this one. You're sizing a DynamoDB table. Items are 7 kilobytes. Strongly consistent reads at up to 3 per second. Writes at 10 per second. What capacity do you provision? B. 6 RCU and 70 WCU. Reads first. 1 RCU covers one strongly consistent read up to 4 kilobytes. A 7 kilobyte item rounds up to 2 RCU per read. 3 reads per second times 2, 6 RCU. Writes next. 1 WCU covers a 1 kilobyte write per second. A 7 kilobyte item rounds up to 7 WCU per write. 10 writes per second times 7, 70 WCU. So 6 and 70. Having the RCU breaks the strongly consistent requirement. Undersizing the WCU throttles writes. Always round the item size up before you multiply. CodeBuild now. There's a hard limit on inline environment variables, and the documented escape hatch is one specific service. Your CodeBuild project fails because the combined length of inline environment variables exceeds the limit. What's the recommended fix? D. Systems Manager Parameter Store. It's the documented escape hatch when CodeBuild environment vars get too big to pass inline. Your build references parameters by name, and CodeBuild resolves them at runtime. Cognito handles user authentication, completely the wrong service. S3 isn't natively integrated for environment variable injection. And exporting a locale variable changes character encoding behavior, it does nothing for the size limit. Parameter Store is purpose-built for this kind of config. Mixing on-prem and AWS now. People love to over-engineer this one. The simple answer is the right one. An on-premises application controls EC2 instances in AWS. The team wants to monitor and troubleshoot the on-prem app alongside the EC2 fleet using CloudWatch. What's the setup? C. Install the CloudWatch agent on the on-prem server with IAM user credentials. The CloudWatch agent is supported on on-premises servers, Linux, and Windows for exactly this scenario. Since there's no instance profile available off AWS, you provision an IAM user with permission to write metrics and logs and configure the agent with those credentials. Bouncing logs through S3 adds latency and parse complexity. An intermediate EC2 forwarder is just an unnecessary relay. And CloudWatch Logs has no inbound read from your server capability. Your servers always push to CloudWatch, not the other way around. CodeDeploy strategy. For names, but the question wording maps to exactly one of them. Your web app runs on EC2 behind a load balancer in an auto-scaling group with desired capacity 5. You want to automate deployments with CodeDeploy and reroute traffic from the original environment to a new one. Which deployment type? A. Blue-green. It provisions a parallel set of instances with the new version, then shifts traffic from the old set to the new set at the load balancer, exactly reroute traffic from original to new environment. In-place updates the existing instances in place. There's no separate new environment to shift to. Immutable is an elastic beanstalk strategy, not a CodeDeploy deployment type. And rolling updates batches of instances within the same environment. Again, no separate new environment. Reroute to a new environment equals blue-green. KMS encryption. This is the question that exposes whether you actually know the API limits. Your team needs to encrypt a 111 GB object using AWS KMS. What's the right approach? B. GenerateDataKey. The KMS Encrypt API has a 4 KB request limit, way too small for 111 GB. So you do envelope encryption. GenerateDataKey returns two things, a plaintext data key and an encrypted copy of that key. You use the plaintext key locally to encrypt your large object, store the encrypted copy alongside the ciphertext, then discard the plaintext from memory. GenerateDataKey without plaintext only returns the encrypted version, useful when you only need to decrypt later, not encrypt now. And GenerateDataKey with plaintext is a made-up API name. The pattern is, KMS protects the key, your code protects the data. Last one. Cost optimization for X-ray, without redeploying anything. Your X-ray bill is unexpectedly high because of the volume of trace data being recorded. You need to reduce cost quickly with minimal disruption, no application redeploy. What do you change? A. Enable X-ray sampling. Sampling rules tell the X-ray SDK how many requests to actually record versus just count. You can drop the recorded rate without changing any application code. The SDK refreshes the rules from the X-ray service at runtime. So no redeploy needed. Custom agent configuration is vague and isn't the specific mechanism for trace volume. X-ray deep linking isn't a real feature. And filtering on the client side requires code changes in every service. That's the opposite of minimal disruption. Sampling rules. Change the rule in the console. Traffic gets sampled differently within seconds. And that's all 10. So how did you do? 8 or more and you're in solid shape for the DVA-C02 exam. 7 or below. That's exactly why you're here. The important thing is, you now know where the traps are. Comment your score below. I want to see how everyone did. If you want the full experience, hundreds of questions just like these, with detailed explanations for every single answer, check out PrepMyCert.com. It's lifetime access, one payment, and if you don't pass your exam, you get a full refund. No questions asked. The link is right there in the description. Go crush that exam.